Determine whether the equation defines y as a function of x. So for most of these examples, the task really will be to solve the thing for y and ask ourselves, are there any values of x that I could put into the equation that would yield two different values of y, right? Because that's what we're looking at in terms of whether or not it passes the vertical line test and follows the definition of a function. So in the first example, y minus 2x equal to negative 3. Many of you, even in that form, may notice that that's a line. I always kind of like to solve it for y, kind of put it in that form y equals mx plus b. So for me, I'm going to add 2x to both sides. So y minus 2x plus 2x equal to negative 3 plus 2x. So I would have y equal to 2x minus 3. I'm going to rearrange the terms there, but that's in that form y equals mx plus b, right? I know that it's a line, its slope is 2, its y-intercept is negative 3. For every x I put in there, I get a real number back for y, so, and only one, right? So I know that yes, it's a function. And if you were to graph this, it would pass the vertical line test, right? For each x value, there would be only one y value. Okay, so let's look at this next one. X is equal to y squared plus 1. Okay, in this example, I want to get y by itself. So I'm going to subtract 1 from both sides. X minus 1 is equal to y squared plus 1 minus 1. So x minus 1 is equal to y squared. And then I want to take the square root of both sides. Now, anytime you're taking the square root of both sides to solve for y, there should be a red flag for you. Okay, so now we have plus or minus the square root of x minus 1 equal to y. All right, so when you have y equal to plus or minus something, because remember that y, when it's squared, whether it's positive or negative, when you square it, it's still positive. So that's how we account for it. We have to say plus or minus the square root of x minus 1. So that means that there are values that I could put in there for x that would give you two different values for y. So for example, let's let x equal 5. Then y would be equal to plus or minus the square root of 5 minus 1. 5 minus 1 is 4, right? And the square root of 4 is 2, right? So you'd have y equal plus or minus 2, okay? All right, so that means for the given value of x, we have two different values for y, right? Both 2 and negative 2. So I would say no, this is not a function, right? And if you graph it, you have to graph both the positive square root x minus 1 and the negative square root x minus 1, and you'll see that it fails. When you graph both the positive and the negative, it fails the vertical line test. Okay. So in this next example, x squared is equal to y minus 5. This is a little bit different. We see that squared term, but I'm going to add 5 to both sides. So I have x squared plus 5 equal to y minus 5 plus 5. So I know that x squared plus 5 is equal to y. Okay, since this is a quadratic, it's going to be parabolic, all right, and it passes the vertical line test. Also, again, any x value I put in there, I'm only going to get out one y value, right? When you do whatever you square and add 5 to, it's just going to be one number, right? So I would say, yes, this is a function. Okay, so let's look at this example of x squared plus y squared equals 4. Again, solve it for y. So I'm going to have x squared minus x squared plus y squared equal to 4 minus x squared. All right, so y squared equal to 4 minus x squared. Okay, so when we have y squared, in order to get y by itself, we have to take the square root of both sides. And in doing so, because y could be positive or negative in there, we're going to have y equal to plus or minus the square root of 4 minus x squared. And some of you may recognize this equation from somewhere else in your life. The x squared plus y squared equals 4. It's a circle, and circles fail the vertical line test every time. So I'm going to say no, right? And also, just algebraically, when we solve that for y, we have another scenario where we have y equals plus or minus something, right? So when we input a value for x, let's say over here on this side, I'm going to let x be 0. We'll keep it simple, right? So that would mean that y would equal plus or minus the square root of 4 minus 0 squared, right? Which is the square root of 4, which is plus or minus 2. So for a given value of x, we showed that we would get two different values of y out. All you need is one example, right? To say, nope, not a function. All right. So in this example, y to the fourth minus x cubed equal to 1. Okay, so again, I want to solve this for y. Y to the fourth minus x cubed plus x cubed, right? Adding x cubed to both sides, equal to 1 plus x cubed. All right, so y to the fourth is equal to 1 plus x cubed. And to get y by itself, I have to take the fourth root of both sides. Okay. And anytime you're taking an even root, the plus or minus deal applies, right? When you're taking an odd root, it's not the case, but with an even root, you got to be careful. Okay, so again, with a plus or minus situation there, we're going to let x be, say, 0. Keep it simple. Then y would be equal to plus or minus. If x is 0, you're just left with 1 under the radical, right? So you'd have, and the square root of 1 is 1. So you'd be left with plus or minus 1. Okay, so for a given value of x, we have two different values of y, so we have to say no, it's not a function. Okay, so let's look at this absolute value of y equal to x. Okay, the first thing that pops out at me about that, I mean, we could solve it for y. It's such a simple one, though. I just want you to think about the absolute value relationship, because we know that absolute value is the positive distance from 0, right? So, for instance, the absolute value of 3 would be 3. The absolute value of negative 3 would be 3. So let's let x be a value. That's what we've been doing in these other examples. Let's let x be, let's use the example of 3 that I just used. So if x is 3, that would mean that y would need to be positive or negative 3, right? Because absolute value of 3 is equal to 3 and absolute value of negative 3 is equal to 3. Does that make sense? Right? So in this scenario, because y is in the absolute value signs, it could be positive or negative in there, right, to yield a positive value for x. So I would say no, this isn't a function, right? We found a value of x where there are two different values of y. All right, now what if it's the other way around? What if we have y equal absolute value of x? Well, then it doesn't matter what x is, right? X could be positive, it could be negative. If we put a single value in there for x, regardless of what it is, and take the absolute value of it, we will get a real number back for y. So in this case, y equal absolute value of x is a function. Okay. With y equal to x over x minus 2, this has a domain restriction, right? X couldn't be 2 because that would make the denominator 0. But all of the other values of x have real number values for y, right? So even though 2 isn't included in the domain, this is a function. And this is what we call a rational function. All right. Also a radical function like y equal square root of x minus 1. Again, its domain is limited. We'd have to say x minus 1 is greater than or equal to 0. But for all of the numbers in the domain, they would have real number outputs for y, right? So I would say, yes, this is a function. So for any of these examples, I wanted us to look at this algebraically, think about values of x that produce the real values of y. Are there any values of x that will produce two values of y? But I would also encourage you to graph any of these using a graphing utility. Ask yourself, does the graph of it pass the vertical line test? Meaning for each x value, is there only one value of y?